In this video, we want to look at the relationship between the unit circle and the real numbers. So for example, if we were to take a number line and if we put it here next to our unit circle, then all of our real numbers here, and we're going to call this point here any real number t, okay? T is just representing any real number, and t is greater than 0, so in other words, t is positive. And if we were to take this number line then and we were to wrap it around our unit circle, then this real number t then would fall at some point on the unit circle. And that point on the unit circle would match up with an ordered pair xy. Just like the over here on the right where we have our unit circle of our special angles, they're going to match up with some point. So that's what we're looking at here in comparing our real number to the unit circle. And of course, that means we're going to rotate around some angle theta. And if we go back to the idea of S is our arc length, is equal to R times theta. So what that tells us, if S is equal to R theta, and we're talking about the unit circle, then that means R, the radius, is equal to 1. So therefore, the arc length is going to be equal to our angle. So if we're looking at angle theta, then in this case, the real number here that's going around is going to be our t value. So in this case, with the unit circle, that tells us that here the arc length t is the same thing as our angle. So what that means, for example, if we go over here to the circle on the right, if we were looking at the point here, let's say at pi over 3, then if we took this to be our t value is equal to our real number, which is pi over 3, then that would certainly correspond to the same location here on the unit circle at pi over 3. Now, once again, notice this is working because r is equal to 1. Now, of course, we would have kind of a similar relationship if we had the unit circle, if we had the number line going down where the real number is less than 0, which means our real number is negative. We could certainly then wrap it around the unit circle this way, and we would still end up with a particular point on the unit circle. Okay, so let's see how we can apply that. If we look here at the first example we have, the direction says that we want to determine the exact values of the 6 trig functions of the real number t. So we've already drawn this out here. We don't know what the t is, and we just want to find whatever the real number t is. We know that that's going to correspond to the following ordered pair that's given. And because we're in the second quadrant, we know that we have a negative x value, so it's a negative 8/17 and a positive y value of 15 over 17. So in this case, they have given us the x and y coordinate for the real number t. And once again, we're talking about the unit circle, so that tells us then if we want to find the 6 trig functions, then if we're looking for the sine of the real number t, then we know from our explanation before of our trig functions, we know the sine function is equal to our y value. And again, because we're talking about the radius is 1, we don't really care about it would be y over r, but we know it's going to be 1. So in this case, our y value is simply 15 over 17. So what we're indicating here is if we're looking for the sine of this real number, it's going to be really the same thing as the sine of our angle theta, because theta and t are the same, because once again, if s equals r theta, r is equal to 1, so therefore s has to be equal to theta. So here t is representing the arc length. So then of course we could go ahead and find the other trig function. So the cosine of t, which would be our x value, and because it's in the second quadrant, clearly it's going to be the negative 8/17. So there we have our sine, cosine, and tangent. So if we find the tangent, that means we're looking at the y over x. So that means we would take 15/17, that's our y value, and divide that by the x, which is a negative 8/17. So we could take the 15/17 and multiply by the reciprocal, which would be a negative 17/8, and therefore the 17's cancel, and we're left with a negative 15/8. And if you notice here, it says find the exact answer, and that's what we're doing here. When it says find the exact, that means we don't want to come up with a decimal, or we don't want to round anything. So here we're leaving it in fractional form for the exact answer. Now, one thing I found out to be helpful when you're trying to find all these 6 different trig functions, I always find them in the same order, and I think that'll be helpful to help you memorize and also to help you from making any mistakes. I always find the sine function, the cosine, and then the tangent. And then when you go to find the other 3, which one is matched up with the sine? Well, that would be the cosecant. The sine and cosecant are reciprocals, so then all we have to do is take the reciprocal of 15/17, so we get 17/15. And then we could certainly find the no, I'm sorry, not the cosecant. We want to find the secant of t, and that would be the reciprocal of cosine, so that's a negative 17/8. And then the cotangent of t is the reciprocal of tangent, so that would be a negative 8/15. So you can see once you find the first 3, the other 3 are very easy to find. Okay? All right, so here we have another example, and we want to do the same thing. We want to find uh, each of the trig functions. And here, I just want to look for the sine, cosine, and tangent, because if we know the first 3, then we can easily find the reciprocal. Now, I would like to ask you to actually pause the video and see if you can actually figure this one out on your own to find the sine and cosine and tangent for this real number t. All right, so if we look at this together, if we take the sine of t, again, sine is going to be our y value, so that means we're looking here at the negative 5/13. And then if we want to find the cosine of t, that's our x value, so that would be 12/13. And then, of course, if we're looking for the tangent, we're going to take our y value of negative 5/13. And we would divide that, so I'm just going to go ahead and multiply by the reciprocal, which would be 13/12. So the 13's cancel, and we're left with a negative 5/12. Okay, so hopefully you were able to get that right. And the next set of problems we want to look at is, this one's going a little bit backwards. This one says we want to find the actual point now. So we're looking for the point xy on the unit circle that corresponds to the real number t. So here we're given the t value, and we can use the circle over here at the left. We know the t value is equal to 2 pi over 3. So we need to locate 2 pi over 3, and we can find that right here on the unit circle. And then all they want to know is what is the xy coordinate? Well, we can easily look here. The xy coordinate is simply a negative 1/2 and square root of 3/2. That's all that they're looking for. Okay, so let's try another one here. Let's say that they give us the number t is equal to, let's say, 7 pi over 6. Okay, so now we need to locate where is 7 pi over 6. Well, once again, if we go over here to the circle, we can easily see right here is 7 pi over 6. And once again, we could actually divide this. 6 into 7 would be 1 and 1/6. So that says we're going to go 1 whole pi and then another 1/6. So over here, this is 1/6 here. So if we go 1 pi and then another 1/6, we would be here at 7 pi over 6. And then, of course, we can see the x and y coordinate would be negative square root of 3/2 and negative 1/2. So when they tell you you're finding the xy coordinate, that's all that we're looking for. We need to locate the angle, and then what is the actual x and y coordinate at that particular real number. And remember here, because we're looking at the real number with the unit circle, the real number and the angle will be the same. And again, that goes back to the idea that S is equal to theta because R is equal to 1. All right, let's try another example. Let's say that we have t equals 10 pi over 3. Now, if we go to the circle, we want to find 10 pi over 3. Well, if we look, we don't see a 10 pi over 3. Now, once again, I told you before here, we probably want to actually divide this. If we take this improper fraction and make it a mixed number, 3 into 10, then 3 is going to go into 10 3 times, right? And then if that would be 9, so then you're left over with a third. So we're looking at 3 and a third pi. Well, if we go over here to the circle, we know that we would have this is 1 pi, this would be 2 pi, and then we need to go another pi, so that means we would end up over here at 3 pi. Okay, so that means we're going around from 2 pi, we're going to another pi here. So there we are at 3 pi, and then we still need to go another 1/3. And if you can't figure out which one of these is 1/3, then if you can always go over here to the first quadrant, we know that this right here going up is 1/3. So that's the third dot. So if we're over here at this point, then we need to go 1/3. So we're going to go to the third dot. So we're going to rotate to here, which would be 10 pi over 3, or the 3 and 1/3 pi. And then, of course, we would have this as our x and y coordinate. Negative 1/2 negative square root of 3 over 2. So the first thing is you got to make sure you locate the real number or the angle, and then we can easily identify the x and y coordinate. All right, so let's look at another example. Let's say that we have t equals a negative pi over 3. All right, so now that we're talking about a negative number, then that means that we're going to go in the downward clockwise position because it's a negative. And again, if you're having trouble with your fractions and we can't figure out which one of these is a negative pi over 3, we can always look once again. If we go up this direction, here's a positive pi over 3, so we want to go to the same location downward. So this point then would be a negative pi over 3, which tells us a negative pi over 3 would be the same location as a positive 5 pi over 3. So really, if we went around positive, we would be at the same location here as the negative pi over 3. And then, of course, we now can locate our x and y coordinate, which would be positive 1/2 and a negative square root of 3 over 2. All right, one last example. If we let t equal, let's say, a negative 9 pi over 2. And once again, I would recommend, because we have an improper fraction, to go ahead and make this a mixed number. So that means 2 into 9 would be 4. So that's 8, and then you're left over with another half. So that's 4.5 pi. And of course, we don't want to forget it's negative. So we need to go 4.5 pi. Well, first we would know that if we went down this way, all the way around, this is a negative 2 pi. And then if we go all the way around again, that would give us a negative 4 pi. So we would end up here. This would actually be a negative 4 pi, but then we still need to go 1/2. Well, we know that if we went positive this direction, this right here is 1/2 pi. So that means we would rotate around this way, and we would be at this point here. And at this point here, we see that we would have 3 pi over 2 as a positive would be the same location as negative 9 pi over 2. So therefore, we would have our coordinates as 0, negative 1. All right, so hopefully now you're familiar with a little bit of making the connection between the unit circle and the real numbers, how we can think of taking our real number line and wrapping it around the unit circle And then we can actually identify here the x and y coordinate that matches up with that particular number.